Okay, so now I'm gonna try to prove here that whenever you have some kind of object, like I said in the previous video, okay, you have a quadrangular pyramid here. So see, this is one of the sides. Well, I'm gonna try to use a straight line. So here's one of the sides. Here's the other side. This is the other side, of course. And here's the other side. Okay, now there's something that I want to show from here, okay, all the way up there. Okay, I think that's enough. So you see, what is gonna be the volume of this pyramid? Okay, it's gonna be, you see, we're gonna integrate with respect to y, okay, and it's gonna be b squared, because I know this looks like a rectangle, but it's because it's at an angle, so it's actually a square. So what is the area of a square? It's the side squared. So the side here is gonna be b, but the side over here is gonna be smaller, okay? This is gonna be the side, and here's another side, it's even smaller, and here's another side, it's even smaller. So we have to calculate. So since we're going to be integrating all these planes, okay, the first quadrangular plane and the second one plus the second one plus the second one, and we're going to sum all of them up. We're going to sum it all up, okay, along the y direction, along this direction here. So there's going to be this plane plus another one kind of in here, right? There, plus another one here, plus another one here. So we're going to sum all of them up along the y direction, along this direction. Okay, we're going to stack them up on top of each other. Okay, so since we're going to do that, we're going to be integrating with respect to y. That means that we have to calculate what the length of x, or of what b is going to be. Okay, now you see that the value of x is going to be just this thing here plus that stuff. Okay, we're going to call that b. That's going to be the value of x. Now, what is the value of this thing here? You can see that here you have the height. I'm going to do something else in here. Here you have the height over here, okay? And here you have something that's, here you have this b here. Oh, this is going to be b divided by 2. Okay, this is b divided by 2, and all you got to do is multiply it by 2, and you're going to get b. But you can see that this height, right, this length right here is varying linearly according to the height. Over here is going to be like this, and over here is going to be like this, and over here is going to be like this, and over here is going to be like that, okay? So it's varying linearly. Fine. So how do we find what the value of b is going to be, okay, according to, let me see here, according to the height? Well, it's going to be the value of x, but the value of x, we're not going to get the negative x. I just want to work with the positive x right here, which is b divided by 2, okay? So you see what you're going to have is, all you got to do is to get this length right here that we're going to calculate, okay? We're going to get this thing, and we're going to multiply by 2. Okay, so x, which is what we're trying to find out, equals twice, because I'm just calculating that this half over here, and then you have what? b divided by 2 times, okay, it's going to be 1 minus y divided by h. So it's going to be twice times this thing. Well, this 2 is going to break with this 2, it's going to cancel this 2, and you just have b minus by divided by h. Now, does this make any sense whatsoever? Yes, because you see, when y is equal to 0, this thing is going to be equal to 0. So we have 1 minus 0, 1 times b. So when over here, when the height is 0, you have all this length of b in here. Okay? Now, when the height, when y, not the height, when y is equal to 0, you have this. When y is equal to the height over here, then the y divided by the height, y is going to be the height. So height divided by height is 1. 1 minus 1, 0, times b, 0. So you see that when y is at this height right here, you're going to have an x of 0. And you do, okay? What about when y is half the height? Well, then x equals b times 1 minus height divided by 2 divided by the height. Okay, so the height divided by 2 is the value of y, and this divided by the height, and this height here is this height here. But actually this height is going to go over there. Okay, so we just put height here. Dividing this by this, you got 1/2. 1 minus half is half, times b divided by 2. So you can see that when y is right in the middle, right around here, x is going to be the b divided by 2, okay? And what is the value of x? The value of x is the side of the square, because then we're going to be able to calculate the area of that square. It'll be it'll be the value of x times the value of x, right? It's going to be, because it's a square, it's going to be this length times another length, okay? It's coming here. This is going to be like b divided by 2, and this is b divided by 2 too. Now I know that it seems that this length is a lot larger than this length, but it's because it's at an angle, it's at a perspective, okay? So let me undo all these things. Okay, that's enough. Okay, so you can cancel these two here, and this is the value of x. All right, so this is the value of x varying. Okay, what is b? B is the length of the side at the base of the pyramid. Okay, that's b. It's this thing. Well, it's already here on the picture what b is. Okay, let me just erase this here. So b is the length of the side of the square at the base of the pyramid. Okay, so what do we have to do? We have to stack all those planes, okay? So it's going to be x squared according to the height, according to the y, plus the next x squared according to the new y, plus the new x squared according to the new y, okay? So it's going to be the integral of x squared dy, because we're varying according to y. But you can't just put an x squared here. You have to express x as a function of y, okay? So we have to undo this there. And what is x? Is b times 1 minus y divided by h, okay? Now the b is a constant. I can just put it here. And then I can do 1 minus y divided by h. Okay, well, it's squared, right? Yeah, it's squared. It's one thing that I forgot. So you know what I can do? Let me think here if I want to do this. Okay, I gotta put this b squared here. Okay, and then, well, I'm just gonna do that. So 1 minus y divided by h squared. Just gonna leave it like this. Okay. and since we're doing dy, and what's going to be what's going to be the value of y? What's going to be the limit of integration? Y is going to go from 0 all the way to the height, okay? All the way to the height of the pyramid. The height of the pyramid is this length here, right? B is this length. Just want you to remember that. This is the height. Okay. So we do that. So what is this going to be? It's going to be b squared. And I'm just going to integrate this here from 0 all the way to h. Okay. Now let's integrate this thing. It's going to be 1 minus y divided by h cubed divided by 3. Yeah, divided by 3. This is going to be huge, guys. Divided by the derivative of the inner function with respect to y, okay, which is just going to be minus 1 divided by h. So you got to put a minus here, and because it's dividing by h, I also have to put this h in here. Okay, now here's the thing. This whole thing is being divided by 3h. The 3h is a constant. Okay, well, yeah, I can just put it over here. So 3h. I can delete it from here. I'm gonna put a let me think. Oh no, hold on. There's one thing that I'm making a mistake here. Okay, so it's gonna be because it was squared, right? It's gonna be this thing divided by 3 divided by the derivative of the inner function. Now the derivative of the inner function is minus 1 divided by h. This, okay, because this minus, it's already here, but because it's dividing by 1 divided by h, it's actually multiplying by h. So I can put the h in here. Okay? That's why sometimes I think it's better to expand this binomial theorem and then do the thing, but whatever. The minus I can put here. Okay. And the 3 I can put it here too. And I can just get rid of it with this stuff. Alright. And now we're just going to substitute. So this equals minus b squared h divided by 3. And let's just put an h in here. Okay, so it's going to be 1 minus 1, okay, times, okay. So putting an h in here, it's going to be h divided by h1, 1 minus 1, 0. So we're just going to put a 0 here, and then you have a minus. And putting a 0 here is just going to be a 1, okay. Do you see this? If I put a 0 in here, it's going to be 1 minus 0, 1 cubed is 1. So this is minus b squared h divided by 3 times minus 1. So you put a plus in here and you forget this whole thing. What did I say? B squared h divided by 3. Remember in the previous video that if if you were not a pyramid, if you were some kind of prism, okay, where you have here you have I'm just gonna draw it this way. Let's just say that you had something like this, which is a square, okay, a square, and it was going up, okay, it was going up like this, and it would have another square here, okay, like that, and here, okay, so it was gonna be like a cube, but a rectangular one. What was gonna be the volume. This is b, and this is also b, because it's a square, so it's going to be b squared times the height. And this right here is the height, this thing here. Okay, that's the height. And that's it. But because the whole thing is varying linearly and it's becoming zero, what do we find in here in the prism? That's b squared times the height divided by 3. So this proves that it doesn't matter what the shape of the base is, as long as the side of the length of the side of the shape. And what if it doesn't have a side? What if it's not a polygon? What if it's a square? It's going to be the length of the radius. But as long as the base is varying linearly with the height, so at the top, at the base of the pyramid, you have the total base, the total area of the base. At 1/4 of the pyramid, you're going to have 1 minus 1/4 of the base, which is 3/4. At half of the height, you're going to have half of the base. At 3/4 of the height, you're going to have 1/4 of the base. And at the top of the height, you're going to have nothing. Okay, as long as it varies linearly, the volume of the pyramid is going to be the volume of the prism with the same height and with a base of the same shape. Okay, the same shape and the same area. So that's it, guys.